Hello, my name is Keegan Haar, and today I'll be going over my assignment 6. First, I'll be going over the changes I made to my files in order to uh, get my new operator of power to work. So first, I had to add power operator to my operator.cs. Then I went over to my expression, and I had to add a case for operator type.power. And for that, like for the actual math of it, I do math.power and then left operand, right operands, meaning that the left one will be the base, and then the right run will be the exponent. And then on top of that, I had a case for operator power here, and then it returns the symbol for it. And then here for a case of the symbol, I return operator.power. That's for my expression. Oops. For my lexer, I just added regex here. So I included that little symbol we use for the to the power of symbol. For my scanner, I added a character next char, and it just again uses that symbol. And then lastly, my EBNF, I add that symbol in the operators. Then in terms of showing you the actual functionality of it, I'm actually on my second program here. Obviously, a lot of the things are the same in it, but so usually in my main program here is where I would take in expression, string expression, and then I would calculate that and parse it and create tokens and all of that, so that the computer would identify that it was a power operation, and then it would do the math for me. However, I'm not going to show you in this program. I'm actually going to show you my test program, the functionality of it. So for my test program, basically I create 5 static voids here, one addition, subtraction, blah, 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 for all the operators. And then I create expression or string expressions there, and then I create the expected. Then I actually find the actual answer to the question by using the evaluate expression, which is basically just doing what I did in the section 11, using the lexer, parsing it, and then telling the program to evaluate it and then returning the value that it finds. So that's what I'm doing here. And then at the end, I'm asserting equal. So I'm saying, does the expected equal the actual? And if not, it'll come back with an error. And if it is, then it will say, hey, it passed. But if it doesn't pass, it'll say it failed. It doesn't just come back with an error. It'll say it failed, and then it'll give you the 2 answers. So you can see the difference and what went wrong in a sense. Anywho, so I will show you, and then I will also make changes to it to show you that it's working. So here you'll see addition passed, subtraction failed, multiplication passed, division failed, and power passed. And so essentially to show you the expected here for the 2 to the power of 16 is the actual answer that we use in our section 11. And so it came back with that the 2 equal each other, as you can see, because it said that the test passed. So I will make a change to that, and then I'll save it, and then we'll try it again. I changed it to 35 instead of 36. So you'll see the error message now. And see, there we go. Expected 655,535, but we got 65536. So it's showing that the expected doesn't equal the matched. So you can see there's actual functionality behind these tests. And I'll change one more. These are failed because I purposely changed them just so you could see what it looked like when some of them fail. But I will change these to equal each other. 10 minus 4. And I'll change the ones that were working to not work now. And again, I will test that. And there you go. Now the one, oops, I screwed up on one of them. But regardless, you'll see now the subtraction actually passes and the others weren't passing. So overall, there's some functionality behind my program, as you can see. And I'm running out of time here, so I better go. Thank you very much.